Okay, I think let's get started. Hello, everybody, and welcome to today's webinar, AI-powered deduplication. My name is Shelby. I'm the digital marketing lead here at Evidence Prime and will be hosting the webinar this evening. The speakers today include Artur Nowak. He is the CTO and co-founder of Evidence Prime being the company behind Laser AI. Today, Artur will be speaking about why we've implemented deduplication and how it will help teams streamline their systematic reviews. More specifically, Artur will also be speaking about what it means to have AI help with this process and what we have to be aware of when using AI-powered deduplication. Next, we have Iga Chiz, the product designer of Laser AI. Iga will briefly take us through the upcoming Laser AI version called Lithium, its features and capabilities. Without further ado, Artur, the floor is now yours.
Thank you so much, Shelby, and hello, everybody. It's an honor to have all of you here. And I will start with some sort of, let's say, technical introduction to the upcoming deduplication module. So this module is being added to the upcoming version by a popular request. We keep track of everything that our current and future clients are telling us and what users miss the most. Deduplication was high on this list, and this is why we decided to make this the focus of this version, as Shelby said, Laser AI Lithium. So without further ado, maybe let's start with the very basics. But I think that even if we perhaps all know what deduplication is, and I think that many of the attendees did it many times in your reviews, I think it's also helpful to kind of look at this from the very basics, because maybe some of the assumptions that we make about this process are actually something that we can rethink. And so first of all, why we need this at all? So unfortunately, the metadata about the publications is not ideal. There are differences in terms of how things are indexed. And at the same time, good practice says that we should search in multiple databases. So it's somehow always the case that we'll face the same publication indexed multiple times and appearing multiple times in the imported search results. So one can ask, why don't you just use some sort of an identifier, like, for instance, DOI or a PubMed ID? And one thing is that these identifiers are very often missing, but the other thing is that we very often have duplicate unique identifiers, which of course is somehow self-contradictory, but that's the case. So a very common case is when we have multiple abstracts from the same conference, all published as part of one proceedings, and then they all are indexed using the same DOI. So even for cases where data on these publications is pretty rich, we still need to pay a lot of attention, and we, for instance, need to look both at the DOI and the title or other fields. And of course, this problem of missing data and inconsistencies is something painfully known to anybody who did this process and had to go through many references to see whether they are duplicates or not. Here on the slide, I have just one example of many ways a hyphen can be indexed in the databases. So when working on this problem, we also became aware that people don't actually agree what a duplicate is. So I think that the most common definition is that we are talking about publications that are indexed more than once in different databases or in the same database, because the databases are also very good at keeping the records clean, but some mistakes can happen. But this definition, I think, is not very actionable, and I think that it's in fact a little bit easier to look at this through the lens of what is not a duplicate. And very often here internally, we call all these other cases examples of studification, so reports or publications that talk about the same study. Another term that I believe is very often used is record linking or report linking to describe this situation where we have multiple reports or multiple publications talking really about the same study. And there are, I think, different levels of this happening. So first, we have cases of the same paper being published in different journals for different reasons. Maybe some of these publications are translations, maybe not, maybe this is just the authors submitting the same stuff twice. A very common case that we had to deal with all the time during especially COVID, with, let's say, wider adoption of preprint servers, is that we have sometimes multiple preprints versus the final paper. Of course, also the conference abstracts and that are then followed by a full report, and finally multiple reports from the same study. So the 4 bullet points that I have on my slide here are examples of something that we don't consider duplicates, but in kind of increasing order, they are about very different publications. But one can actually also treat some of them as something that they would consider a duplicate. So for instance, the preprints. So I just want to acknowledge that some definitions are needed, because I think that depending on the use case, people may actually assume different things when talking about deduplication. At the same time, deduplication and what we call studification is part of the same spectrum. And I think that this will also become more clear when I will tell you about some radical idea that one of our colleagues came up with. So the radical idea is as follows. Maybe we should deduplicate after abstract screening. And the idea here is that if we have 2 abstracts that are very similar, and they are basically talking about the same thing, then we expect that they will be either included or excluded together. So even if this is not the same publication, even if we have different authors, but we have abstracts that are so close semantically that they should both either fulfill or not fulfill the eligibility criteria of a review, then it really doesn't matter whether we deduplicate them before the screening or after screening. And so this radical idea is about deduplication based on meaning, and not about and not based on, let's say, the publication details or whether this is an entry in a journal or a conference abstract, for instance. So in this case, the whole idea here is that we are not really so interested in deduplicating excluded studies, because if something is excluded, if something is not, it doesn't lie in the scope of this review, then maybe we just don't need to spend time on deduplicating these references, looking at them. So in this approach, the idea would be that we are only checking the included studies. So I will use this diagram to explain this once again, that if we start with individual publications, individual records from the databases, visualized here by these colorful lines, and then we do this semantic grouping, and we have 5 clusters that are very similar in terms of meaning. And then we do screening on these clusters. So we are basically using one of the representatives, or maybe all of them together, to do the screening. Then in the end, we are left with just 2 of these clusters, and we can do the deduplication only on these 2 clusters, and then find out how many reports we really have, whether we have 3 reports or maybe 2 reports. This is something that is kind of becoming a very natural thing when we fetch the full text documents, because if we cannot fetch 2 different full text documents, then most likely these 2 references are just duplicates. So I'm presenting this, and just to end this kind of suspense, this is not the approach that we are proposing and that we have implemented in Laser. But since I believe these webinars provide some space for a very interesting discussion and for a meeting between our team and experts in the field, I just wanted also to include this idea here, because I believe that while this is not compatible with Prisma and not suitable for systematic reviews, this idea may actually find application in other types of synthesis. So, for instance, if we are just doing some sort of a, let's say, landscaping of the literature, and we have very limited number of abstracts that we can review, then it really makes sense to provide some, let's say, heterogeneity among these abstracts. So we are not really so much interested in finding out whether we have duplicates or some abstracts that are so close that they're almost identical. If we are willing, for instance, only to review 100 abstracts, then it's just a good idea to kind of provide different types of abstracts and then think about mapping them to the actual publication as the second step. So I'm describing this idea, hoping for a lively discussion today or as a follow-up. And because I think that this is an interesting thing to kind of look at this a little bit out of the box and to challenge our understanding of what this deduplication is, why we really need to report a number of removed duplicates for studies that we exclude anyways. So looking forward to your questions. And now kind of getting back to where we are at the moment and talking about the classic approach. So what we call the classic approach, which I believe here is well represented by the method developed by Brammer and colleagues, is that we first fix formatting in the key fields. So some of the fields that we have for the records are necessary to perform the deduplication, but they, as we saw in one of the first slides, have different formatting differences, and we want to kind of make them more consistent. So this formatting fixing can involve stuff like making everything lowercase or replacing hyphens with something which is the same across all the references, or maybe even removing the special characters. People are also doing stuff like removing all the non-Latin characters or converting them to their Latin counterparts. So there are many formatting steps here. And then what follows is making an exact comparison, exact match on some number of fields that we feel that we think are really unique across different publications. So in this method that we have here, author, year, title, and journal, these 4 fields are considered to be unique for every separate publication. And it, of course, makes sense because it's very unlikely that, that any journal will publish a paper that has the same title in the same year from the same authors. it's very likely that the editors will encourage the authors to change the title if they really want to submit something that is titled exactly the same. Very similarly, if we have some, let's say, ambiguity in terms of the journal, the second option here is to look at the pages. And I believe that this is a good proxy for the journal. With journals, we, of course, have differences in naming. Sometimes it can be BMJ, sometimes it can be British Medical Journal. So pages are kind of very unlikely to happen by chance. I mean that in different journals will hit the same and a paper with the same authors and the same title on the same pages. So I think that pages are kind of serving as a proxy for the journal here. And then what happens, and this is my third bullet here, if we cannot use these exact matches that kind of uniquely identify papers, we are switching to some subset of these fields and filling in for the missing field by making manual checks. And this is something that is described in this figure as points C to G, where you can see that they are at some point looking only at the title, but in the notes they say, but don't look at the title only, please compare the page numbers. So you first sort by the title and you're kind of doing this comparison that couldn't be done by exact matching. So now you're using your natural intelligence to really see whether, for instance, the pages are the same or not. Maybe it's just because of some formatting changes. So now with the obligatory image generated by AI, I introduce our method, which is called super deduper. And this is a little bit like a hybrid of the classic approach and the radical approach that I introduced earlier. So the idea is that we first follow the classic approach, so we can very precisely say how these references match, how they are grouped together. And then instead of making manual checks, we delegate this to AI using the semantic similarity. So this allows us to use some of these more, let's say, more relaxed rules. So something that you typically find in these algorithms to the bottom of the list, but without necessarily having to check this all by hand, because the checking is really done by AI. And what we also think is crucial here is to have transparent communication of how certain we are. And this certainty is based first of all on what rule was used to make this match, and also on the, let's say, level of this similarity. So we thought that what is really important when introducing a new method is to have an external validation. So to find a data set that was used to test deduplication methods before. So we are not kind of cherry picking the results. So we have some sort of a good understanding of how this method compares to the current state of the art. And before I share the results of our validation study, I just wanted to spend a minute or two to kind of explain what metrics are reported in this kind of papers. I myself, I'm very often working with, let's say, screening models. I find it kind of counterintuitive how the metrics are tracked here. So it makes a lot of sense how these metrics are defined in the deduplication literature, but just to avoid any confusion, let me walk you through this very quickly. So first of all, the worst thing that can happen is to have a false positive, which is very different to what happens in screening. So, so false positive here means that we identified something that is not a duplicate, and we mark this as a duplicate. So this means that false positive means that something that should stay in goes out. False negative is much less of a problem because it means that we missed a real duplicate. So something that we could potentially exclude and save our users that do screening time, we still included, so they kind of unnecessarily need to screen some extra references. So the metric that is connected to false negatives, so how well we are doing in saving time, is sensitivity in this case. So how many out of all the duplicates have we identified? And the metric that is the measure of safety and that needs to be 100%, here in this literature is specificity. So which tell us how many of the detected duplicates are really duplicates. So I think that this is very close to what we also have with diagnostic tests, but I just wanted to make it super clear what these different metrics mean to avoid any confusion. So we took a study that compared multiple methods with manual deduplication, called here manual abstraction. So you can see that there are a couple of different reference management software compared with review software and also searching through Ovid. Our idea here is that we are using a publicly available benchmark, so we can also kind of test ourselves on something that we haven't seen during building of the system. And this particular data set is available as open data. It's coming from a publication by Mike Keon and colleagues from 2021. Our method is performing very well here. We had no false positives, which means specificity at 100% and 95% sensitivity, which is even better than searching through Ovid. So now the next steps that we are doing is to find more public benchmarks like this one. Unfortunately, it doesn't seem that there are many papers that publish their evaluation data. So we identified two, and we'll be running these tests on the two benchmarks that we found, including one large scale for preclinical studies. And here we would be really happy if you could share some examples with us, maybe something that we couldn't find. Maybe you have some good examples, some data sets that were tricky to deduplicate, so we can test our tool and compare this against the gold standard. And also because our scoping review showed that there are, let's say, lack of many benchmarks, we decided to create somehow artificially or create some sort of a synthetic benchmark with focus on making it difficult. So of course, having benchmarks that are real reviews is of great value, and I would really like to see more of these benchmarks. But at the same time, we also wanted to have something a little bit different, something that could potentially show problems in the current approaches. And there are a couple of things that we consider difficult in this domain. So large number of databases. So we in our data set, we include reviews that have more than 7 databases being searched. Missing abstracts. This is something that is particularly difficult for our approach. Conference abstracts, study registry entries like clinicaltrials.gov, but also other registries. And I think something that is very underexplored at the moment is if we have many languages that we need to deduplicate across, both in terms of translated titles and abstracts, but also untranslated ones. So all this work is ongoing, and we also hope to publish a paper on this. So we would be very happy to both, and we are seeking your help in finding good benchmark data sets, and we would be happy to also work on this manuscript with other people. So please reach out to us if you find this interesting. Okay, so that's my part, and I hope that this will, let's say, trigger some sort of a discussion. I tried to maybe question the current status quo. And now I'm handing over to Shelby and to my colleague Iga, who will walk you through the upcoming features of the new version.
Great. Thank you. So I hope you can hear me well and see my screen, and that's the most important part. So hello everyone once again, and I'm happy to be here and present you the new laser version, Lithium, which is just around the corner. I will briefly go through the main changes that we have prepared for you over the last quarter. But at the same time, I strongly encourage you to sign up to our newsletter. If you haven't yet, once the new version goes live, we will send you a more comprehensive summary with details on how you can take the most of new functionalities and what exactly changed. So my presentation today will be divided into three main parts. One, where I will mention new functionalities in the reference management, and then we'll go to the focus mode and the changes in the interface there, and the last, the changes in the data extraction view. So about the application, you already heard quite a lot from Artur. So it's not only the topic of today's webinar, but it's also a key theme of this release. And when we were working on the application, we've learned that everyone's favorite part of this process is actually when it's already completed. So here we go on an extra mile to ensure that the application process won't take you much time, and while also maintaining high precision and safety. So I will solely focus on the changes on the interface right now. So as you already know, the main part is obviously models, which will be running right after we will upload a RIS file to our new project. And we'll start processing the file. After a while, you will get an exact number of potential duplicates. This information will be visible here on the main project dashboard and also on the reference page. So these duplicates will wait for you and your colleagues for verification. You can already jump to the remaining part of the batch, which will be available for distribution, but strongly encourage you to check them before starting screening. And what we can do here is just click on the information about duplicates that were found inside of the laser, and you will be redirected to deduplication mode. So deduplication mode is a view where we can only focus on duplicates. Here they will be grouped into 4 sections based on the confidence level with which they were marked as duplicates. As you can see here, each duplicate is visible under the primary reference. We can easily compare them by looking on the popular data like DOI or pages from the journal. If this information is not sufficient, we can always take a look on the right panel here. The right panel, we are doing for you comparison of the bibliographic data between primary reference and the duplicate, so we can easily find, following the visual information, which value didn't match perfectly. If anything was incorrectly labeled as a duplicate, we can simply remove the label. Also, more complicated batch operations are possible here, like removing a duplicate label to many of them at once, or group references just by using the checkbox here. Okay, if everything is done and we are sure that all the references here are correctly labeled as duplicates, all we have to do now is to use the confirm all button. Okay, once done, the new status will be moved to the main list of references. So if we have changed anything from the duplicate to the main references, it will be going now to the main list. And also we will be going to the next group with a little bit lower confidence level. So, of course, if we want to recheck some duplicates, or, for example, export the entire set of initial references, we can always find them. Right now, they will be available in the reference page here. By default, we will display here the main list with the references that are going to the distribution, but you can always switch it by using the drop-down here to the list with duplicates. So we are already here. As you can see, the duplicates are visible in two different phases. The one gray means that these duplicates were already confirmed, verified by us, or they were done manually. And the orange or the peach color label means that these duplicates haven't been checked yet by our colleagues or by us. And speaking about the manual selection of the duplicates, it will be done slightly different than previously. So right now we have to mark both duplicate and the primary reference to basically link them together, and then click mark duplicates. In the last stage, you have to only check if the primary reference is the one that you really need, that you really want. You can also compare bibliographic data, and we've done. Okay, so the application is not the only enhancement that we are trying to provide you with the new version. We are also trying to help you with PDF retrieval. And in the Lithium, the new version, you will get integration with two external providers. So one is the OpenAlex. Perhaps all of you know it's the largest provider of open access PDFs. And also Article Galaxy, where you can find both paid and free publications. So when you click under the chosen provider, you will be redirected to the page where you can see a preview of the respective PDF and download. So in the second part, as I mentioned, we are going to the focus mode. So for those of you who haven't used Laser yet, a focus mode is a special view where you can basically focus only on one abstract or one PDF. You have only information that are needed to make a decision. And here we went a little bit further when it comes to reducing distractions and let you finally get the laser focused on what you have to do. And in the previous version, we have provided the first part of the changes in the full text view. There you were able to resize panels and, for example, change the PDF zoom as well. And all these different settings were saved to your profile. Now, exactly the same flexibility will be available in the title and abstract screening stage. So here we have two well-known side panels, one with the decision as in the full text stage, and also the right will have panels with content that could be changed regarding to your needs and preferences. So as I mentioned, we could, for example, resize a PDF. Now we don't have a PDF here, but we can change the size of the font used in the middle part. This is also something that will be saved to your profile. And similarly, the bibliographic data was unified across entire application. But you don't have to worry, it will be possible to adjust it to your preferences and context of a specific stage. For example, if you prefer to use mesh terms, it would be rolled out or rolled in on the title and abstract screening stage, and these preferences will be also saved to your profile. So changes are also visible in conflict view. And here on the list, you will be able now to filter available conflicts depending on the type. So whether it's a conflict that was generated by you and your colleagues or by other researchers, and you would like to resolve them as a third researcher, you can filter them right now in the left filter panels. And after entering to the focus mode, you will find very, very similar, clean and unified version of the focus mode, and will be looking exactly the same for both screening stages, so title and abstract and text. Okay. So the last part is data extraction, and here the very important but change that we've done is also very hard to show on the presentation. This is something that you have to try on your own. We spent some time improving the interaction with the PDF file, and now selection and verification of the model suggestion should be much smoother than previously. Extraction from table. This feature was provided to you in the previous version, in the beta version. So it was warmly welcomed, but at the same time, we learned a lot what could be improved and changed. And we already done some improvements to give you a better experience. To start extraction from table, you have to now click twice. Once to activate the table, and on the top right, you will see the blue button with the extract and the table icon. And to open, as previously, the same model, you have to click now on the blue button. Thanks to that change, right now, if you, for example, would like to extract just one value from the table, or maybe there is a link inside of the table, you can still use it, there is no problem. Also, the model, the dialog that will be displayed after we start extraction from the table will look slightly different. Once you select the proper section from the form, you will see the first object on the right of the model. So this is a kind of a live preview. So it's not only showing you if the mapping from the table was done correctly, but also you can, for example, pick one value from the vocabulary, which is kind of overarching category for each object that will be created at the end. And also you can type something in a text type of field. Okay, so it looks like that. As you can see, after mapping the values from the column, these are visible on the yellow backgrounds, and the one that we have chosen manually are now visible on the blue. Nothing changed in the view after the extraction, but if you would like to go back to the table extractions once again, here you will find some improvements because the previous selection will be remembered for you, And also the slightly darker background, you will see values that were already extracted before. Last but not least, we also changed to change the connection part here. Right now, you will be able to instantly say which type of connection should be established between different objects, what was already done, and I hope nothing will be left any longer. So that was all from my side. I really hope that you will find those updates exciting as we do, and I will be waiting for your feedback. So thank you, and back to you, Shelby.
Thank you very much, Artur and Iga. This was really great. We have a number of questions, both in chat and in the Q&A. I also noticed that we have 2 hands up from 2 attendees. I just want to clarify if these attendees would like to speak live or if they just want to type their questions. We're more than happy to have both of those. I just need confirmation on that, please. Let's start with the Q&A questions until we get some clarification from the other live attendees. The first question we have in the chat is, it's unclear to me why 2 identical or nearly identical papers published in 2 different journals wouldn't also be examples for deduplication. Thank you.
Yeah, so I can take this one. So I agree. They are in fact duplicates. But you know, when we scan the literature and when we looked at how people defined duplicates, and also kind of looking through these data sets, it was very clear that for the sake of the evaluation, these are kind of considered to be 2 separate publications. So I think that this was really my point, that even with something as basic, seemingly, if you dig deep enough, there are some differences in how people approach this. So, you know, every problem really shows its depth once we start working on it. This is really something that we encounter over and over again. Here, this was one of the examples of something that I think is also not entirely clear. So in our approach, the idea is that you know, it's quite easy to mark such 2 publications as low confidence duplicates, so people will still need to decide what to do with them. But I think what this question highlights is that some flexibility also needs to be required or is required in a tool that you use, because people just may have different definitions of what they consider a duplicate.
Great, thank you. The next question we have is, what databases do you recommend for medical field?
Yeah, so I think that the classic answer here is to use you know, Medline and Embase, but this really depends on type of the review, of course, and even the geography. I'm a little bit out of my depth here. We have a team in-house at Evidence Prime that kind of specializes in this. So I guess many attendees are probably much more knowledgeable than I here. So please feel free also to answer in the chat if you have a better answer.
Perhaps that's another webinar topic for the other members of the team. I believe this is a question that might even be related to the previous one, which our team has an accumulated database that currently contains over 100,000 citation records. We search multiple databases every year to identify new citations. What is the capacity of Laser AI for processing duplication check?
So I think that, you know, this question highlights something that is also very important, and namely the performance of the methods. So we know, and here we are talking both about how long it takes for the tool to run. Again, looking at the literature, And one of the papers that I had on my slides, the one with data sets in preclinical studies, they had a data set with almost 80,000 references, and they said that one of the tools ran for 48 hours on this data set. So of course, at this point, it's a little bit, let's say, unusable, simply speaking. But at the same time, we also had this experience of supporting the McMaster team that was doing living review as part of American Society of Hematology COVID guidelines. This was one of the topics of one of our previous webinars. If you're interested, we can post a link, or you can find the link on our YouTube channel. And in this scenario, at some point, we had close to 500,000 references. So with this volume, if we are talking about 95% sensitivity, so this means that 5% of duplicates become, are not noticed. 5% out of 500,000 is really a lot, right? So, I think that with the scale, everything starts to work a little bit differently. In our case, I mean, kind of coming back to this example of a massive review, this is really where this radical approach was born, because it became aware, very clear to us that with 500,000 references, we cannot really do manual deduplication because this will steal time from doing the screening. So we haven't applied this approach, let's say literally, how I have had it on my slides, but we perform much more of the automatic check. So I think that scaling up to this number of references that you mentioned, 100,000, is well, let's say, in the let's say reach of the technology, but it will typically require running this for some time. I mean, it won't be instantaneous, and also depending on how many new references are added every month, it may require more, let's say, AI supervision versus manual supervision.
I may have missed it, but for the PDF retrieval, do you need to go through each reference one by one to retrieve the relevant PDF, or is it possible to do a batch download for multiple references?
Yeah, so I may take this one. So unfortunately, for the time being, you have to go one by one. This is our first version of this functionality, and we are working on making it a little bit easier for you. But yes, right now, whether you are manager or a researcher, you can do it from both places.
Okay, perfect.
Yeah. And if I just may add something to this, so this is something that we will most likely cover in our upcoming webinar. But what we became aware of is that it's becoming very difficult to fetch even open access PDFs automatically. So, and I believe that, based on our experience accessing these databases, it's kind of a problem that is increasing right now, that even if a PDF is in open access, the publisher is putting some sort of there are some gatekeepers that prevent automatic downloads. So they are kind of only allowing to, or maybe they need to track these downloads and see, how many unique users download these PDFs. So for whatever reason, on our, let's say, non-scientifically chosen sample of 100 references, it turned out that for 100 references that had open access links, we were able only to automatically fetch around 10%. So this means that, for us, it's not really a big problem to add this functionality to do the batch retrieval, but then people will be quite upset that this batch retrieval only gives them 10% of all the references. So we are now working on some sort of a solution to this problem, and hopefully we'll be able to share this during the upcoming webinar.
Next question, are there any other interesting features in data extraction? Also, is there any way we can decide on the different rows we want to make for the different interventions?
So I think that there are many, let's say, smaller fixes and also larger fixes in this upcoming version. So in terms of the extraction, we don't have like super big feature like we had with table extraction last time. Now we are kind of focusing on addressing the feedback that we get from the users, and I think that it will probably become our little tradition that every second release we have something big to share with you, and then the following release is about getting the feedback from this launch and fixing the usability and other problems. So this release, I think that this was the theme of my presentation, that we kind of looked at the feedback that we got. Of course, the deduplication is for us a huge step forward, but in terms of the extraction, you can expect something brand new in the next release, which will be available around autumn. Now we are kind of focusing on making the models better, making the accuracy better, and also improving the usability of things like table extraction that Iga shared with you.
Moving on to the next question. Once you obtain the papers, can the AI extract the needed data from articles into a database?
Yeah, so I think that this is really what is facilitated by this data extraction module. We are not saying that this is done fully automatically, because in terms of the AI hype, we are, let's say, among the teams that work on this problem since 2018. So we went through multiple hype cycles, and then we are kind of painfully aware that it will take some time until we make it perfect. So our approach is that we try to pre-populate the data extraction form with the suggestions, but they should be reviewed by a skilled professional.
Moving on to the next question, does AI give authentic results?
I think that, of course, this question can be kind of understood on many levels, but I think this also opens an interesting question about whether we are able to spot any problems with scientific integrity, because of course, in terms of the whether the results are authentic, in terms of whether they are true to what is written in the paper. Yes, this is, let's say, our primary metric, and we even go to such a let's say great we walk an extra mile to, for instance, make sure that anything that we extract can be supported by what's in the paper. But of course, if the reported values are not, let's say, true, then how we can spot it? And here, I think that this is a very interesting avenue for research, and I'm now also becoming aware that people are looking into how they can apply AI to spot problems with scientific integrity. And this is something that we would like, of course, to also include in the tool somehow.
How you choose which record is the main one and which are considered duplicates?
And this is a great question, to be honest, because multiple strategies are possible. And I think that the holy grail is to kind of merge the references. So we have the most complete version kind of glued together from all the reports that we have. But this is something that we consider as a second step. We don't really know how to do this without causing any harm. So right now, we are picking the first reference based on, let's say, the study ID. And this also opens the possibility that we kind of sort these references by some other criteria first. So for instance, always to have one with abstract, and so this one will be selected as the primary one. But we would really like to hear from you how you approach this and what we can do to follow this workflow.
Okay, perfect. I think let's do the last question. Can you override what super deduper does?
Yeah, so maybe I will take this one. Obviously, yes, you can. As I showed in the second part of the description of the application, you can change manually after you already confirmed or suggestions from the model, but also inside of the application mode, all type of changes are possible. You can group them together, you can change the status and set other primary report.
Okay, perfect. Thank you so much. That has kind of got us to 6 p.m. on this side and is the end of the webinar time. We want to really thank you for attending. Arthur and Iga, thank you very much for your presentations as well. Please feel free to reach out to us with any questions via the website. You can book a demo. You can ask any questions on our emails. Kirsty will also add in some information in the chat for you down below. I will also share my screen just with 2 QR codes to our YouTube channel as well as to the website. But otherwise, that is it from us today. And thank you very much for attending.